Hi everyone, channel. So in this particular video, we are going to understand about LSTM. So LSTM basically means long short-term memory. So this is particularly a deep learning technique that we use for uh, NLP, that is natural language processing. So this particular architecture actually looks complicated, but it's very quite easy to understand. So be with me. Uh, be with me. I guarantee you guys, after this video you have no doubts about LSD. So before going through this particular architecture, so let me understand, like let me discuss with you guys, like why we basically need LSTM, like in what case we actually use this particular LSTM, then we'll come to this particular architecture. So let's understand with an example. So let's take an example. So I'm taking a sentence, right? So suppose you are taking one example of fill in the blanks. So let me see how LSTM is going to useful. So the sentence is something like Sam eats paratha every day, and it should not be hard to guess that his favorite cuisine is. So favorite cuisine is what? So if you want to fill the line here, so basically if you want to fill the line, so you have to concentrate on what? So what it is, like he's eating. So basically paratha, right? So if you concentrate on paratha, then you can say what is his favorite cuisine. So let's see. So basic traditional RNN. So actually LSTM is developed after RNN, right? RNN has some disadvantage, like uh, it has vanishing gradient and exploding gradient is a problem. So let's see how the traditional RNN will act upon this particular example. So what happens? You know, guys, in RNN, what you do? Each RNN cell will be uh, loop through each other output. Like it has one cell, but that particular output will be given to the same particular cell. So what happens? So first for the first timestamp, this particular word will be sent to the cell. You can say this is the first timestamp, and this is second timestamp. So this is second timestamp. So for each timestamp, this particular word is injected to the cell. So Sam, then suppose we have first started initialize as Sam, then second timestamp which we pass eats, then paratha. So when paratha will, like when it will come, so as it is sending the previous output as well, in RNN. So what happens? The same word also be there in the cell. In the next, in the third timestamp, when we are sending paratha, so it has the previous output as well. So in previous input, so what was the previous input? It is eats. So it has eats and the current output paratha. Then after that particular time we are sending what every day. So in particular that cell every day, the paratha, so the previous output will be there. So paratha and every day. So when it will come to this particular phase, so is, so last word is what? Last word is. So when it will come to is, so what happens? What is the before timestamp of this particular is? So it is cuisine, right? So it has is and cuisine. So you can identify the example, right? So is cuisine. So when the memory has this data, right? Currently the memory has the data. So all this data has already vanished. So when the memory has the data and it wants to predict, so what it will predict? It has previous information only cuisine. So there is no information about paratha. So if it has paratha information, then only it will predict what type of cuisine he's liking, right? So the RNN is not able to predict this particular cuisine because it has some issue of what, long term dependency. But let's see how the LSTM is going to work and how the LSTM is going to more beneficial. You can see, let's take one example. The same example we have just modified a little bit longer. So Sam eats paratha every day. It should not be hard to guess that his favorite cuisine is that we want to predict, right? So this we have LSTM. Let's see. So yeah, and his brother Raz, however, lover of pasta and cheese. So that means Raz favorite cuisine. So for second line, you can say this particular pasta and cheese is the important word to predict this particular dash. As for first line, paratha is important to predict or to say to fill the blank. The for second line, for brother, the pasta and cheese is important to fill this particular blank. So let's see how LSTM gonna help for this particular for these two sentences. Okay, so for let's see how LSTM network will basically work upon that. So LSTM network, what happens? It only saves in the memory, like the memory concept is applied in the LSTM. So we'll go through the architecture. Once we'll go through the architecture of LSTM, you guys can understand. So basically, what happens in LSTM network? Only important information will be saved in the memory for long-term memory. In the long-term memory. So first word is Sam eats paratha. So when the paratha word it will come, the paratha word saves in the memory. Or else there is nothing. There is nothing. So first word it will when you go through this particular cell, LSTM cell, nothing will be saved in the memory. Eats, then eats word come, nothing will be saved. When the paratha word will go to the memory, then it is saved as paratha. Then next word every day. So unless one more important word will come, the paratha word will be saved in the long-term memory, right? So the paratha is saved. So when the is word is like before the dash, the first sentence. So what we have seen actually, if you go through this particular example, what we have seen. So before this particular line, or before this particular line, is there, right? So in the LSTM architecture, when is when up like when is will come, is timestamp will come in that particular cell, it has paratha in the long term memory. So as it found paratha in the long term memory, so it can easily predict which type of cuisine is liking, right? As paratha is a Indian cuisine, so it will predict Indian, right? It will predict Indian as a long term memory. But how it will predict for the next line? So what was the next line that I have told you? So next line is his brother Raz, however, lover of pasta. So you can see how the context is changed, right? So let's see how the LSTM architecture will give the output. So after that particular Indian word, so this his brother Raj, however, lover of pasta and cheese. So this word will be projected to the cell, right? So let's of Indian. So then word. So paratha is there. Paratha is already there. Unless it will another important word will not come, the paratha will be saved in the long term memories. Next the next sentence word will be injected to the cell, LSTM cell. So his brother, so that sentence word will be projected. Then when the pasta will come, the paratha, the word uh, that has been saved in long term memory, it will be replaced after the pasta word will come. So when the pasta word will injected to the memory, so it replaced the paratha word will be replaced as pasta, and so pasta and cheese, right? So pasta word will inject, then the paratha word will be removed, then removed, and pasta word will be saved. then end will be passed, as end is not that important, it will be the pasta will be saved. And cheese, when it will find cheese, cheese also important word as pasta. So in long term memory you can say this, it will save pasta and cheese, and paratha word is forgotten, the memory forgets this particular paratha word. So when the ease will come, when the ease word will come, the long term memory, the like what memory has in the particular long term memory, the pasta and cheese word, so this particular word is there when the ease will come. So as long term memory has pasta and cheese, so it can easily predict which type of cuisine is that, this is Italian cuisine. So so what happens in long term memory, so we have forget layer in the LSTM. So what it is doing basically, it is forgetting when other important parts come. So if you go through this particular example, you can have some basic sense, this basic sense of how the LSTM network works, and what is mostly what it is mostly useful for, right? So basically what it is doing, it is remembering the important word. So 2 points you have to remember. So it is remembering the important word which is necessary for the prediction of any dependency words for the for this particular word. Suppose paratha, so in for the cuisine word paratha is important, so it is saved in the long term memory. So when the until the next important word will come, it is there in the long term memory. So when the next important word will come, it will forget. So forget layer is there, it will forget paratha, and this particular pasta and cheese will be saved in the long term memory, right? Then after that it will predict what type of like it will predict as per the data it finds in the long term memory. So this is basically overview of how LSTM network works. Then actually we'll go through, so then actually we'll go through the architecture. So I think you guys understood about the basic overview, or you can identify